So I was just testing something, and it turned out to be way easier than I thought. I didn't record it because I didn't really expect it to work this easily. One of the things I need to do is when you change the size that this thing is allowed to move to, it needs to pull um, all of the moving pieces in case the size is smaller, so they don't end up out of bounds and stuck there. And it should also randomize their positions and velocities, just so it's not always the same. And you could do that by connecting, a LogiX node to every single one, but I had never used slots before, and I thought I would try that and see if I could uh, randomize a position using slot logic, so I don't actually have to connect any logic to each one. I just write a loop that loops over them and sets them, and it's actually really easy. This box is the main object. This little one and this little one are children of it. And I have a bit of logics here that every time it receives a impulse, it sets the small boxes to a position that's random between, -1 and 1 in all three components of their position. And that wasn't hard to do. What I did is I gave each of the children boxes a tag so I can identify them. I just call it tag 1 for testing. Actually, all this stuff back here is not doing anything that was testing. So let me get rid of that. It's even simpler than it looked. Okay, so this is all there is to it. Can you see that okay? So it's a for loop, and that loop takes an impulse, which I just have hooked up to a manual impulse there. It takes the children count, iterates over every child, doing a get child. If the child has a tag, which I just changed, come on. If the child has the right tag, tag 1. So get child has tag, tag 1. If that happens, then it sets its local position to this random float 3, which is just going from -1 to 1. So that was easier than I thought. I can apply this to the Mystify screensaver quite easily. I don't know why I hadn't done anything with tags until now. They're not tags, slots. They are quite simple to work with. Slots, and I'd never used a loop before either. Slots and loops, and I'd never used a random. So slot, loop, random, all pretty simple to use once you understand the basics of impulse-based logics. Okay, I am re-recording one segment of this Mystify screensaver example because it did not go well the first time. What I did a few days ago, and you probably just saw a few seconds ago if I included it in the video, was using the slot LogiX nodes and a for loop to set the children of an object to random positions. And I'm going to use that to make this thing up here reset itself to a valid range of positions whenever we change the distance limit here. Now I also I also want to change the velocity and color on these, but I can't do that using the slot logics. Let me show you why here. If we look at something, let's say we look at a sphere here. Let me bring you in closer so you can see this better. So we are looking at a sphere in the inspector right now, and you can see, if I can get you looking at it straight, the slot is basically each object. So the sphere object has, among other things, at the top level of the slot here, position, rotation, and scale. And there are LogiX nodes to set position, set rotation, and set scale. So if you iterate through a bunch of slots, you can go in and change all of these variables, which is fine if we're changing its position. But if we wanted to change its color, that is down here. There is a material component, and there are color properties on that component. So from the slot, we would have to somehow get the material component and get the color property of that component. And there aren't any LogiX nodes to do that right now. So you can set the position, rotation, and scale. You can't change the color when you're looping through slots. Likewise, the velocity is stored in a variable, and if we look at the velocity variable here, we could go in and set the position, rotation, and scale of the velocity variable, which would be completely pointless because there's nothing visual showing up with this. But if we wanted to change the value, that is part of the float3 register component, X, Y, and Z properties. So we can't change the velocity when all we have is a reference to a slot either. Which means I'm going to have to go in and modify this thing and just connect LogiX nodes to each individual sphere that is bouncing around if I want to set the velocity and color. And I could just as easily set the position in the same way, but the whole point of this thing was to be a LogiX example, and we might as well show another way of doing things even if we can only change the position, rotation, and scale using this method. Okay, so I am going to go in, not do that. I was trying to open the scene inspector that I just closed for some unknown reason. I'm going to go in and start modifying this thing. Remember, we had two groups of things here, one for the blue bouncing lines and one for the red bouncing lines. I will just start with one of them, I guess. So what we want to do is when the distance limit changes, we want to go in and reset the positions so that if the distance limit is lower than it was before, you don't get the control corners stuck outside the range and jittering back and forth and unable to move. So I will start by opening up that distance limit, getting a LogiX reference to the Neos numeric up down, and there is the value. So we want to do something when that value changes, which means we need a LogiX node. It should be under flow, fire on change. If the value changes, we want to get an impulse. So I'm going to turn that off for a second. So if I change it to 4, 3, 4, 5, 4, it's firing. So that gives us an impulse whenever we change that. You're zoomed out a little bit too much, aren't you? Sorry, I am not a very good cameraman. Try that. Now, when that changes, we want to go through and change the positions of all those spheres that are at the corners, acting as the sort of control positions for this whole thing, which means we're going to want to loop through each group. Oh, you know what? I forgot to do one thing that I did when I recorded this video previously. In order to know which objects we're setting the position on, I'm going to assign a tag to these, and they are going to all have the same tag. Okay, all 8 of the spheres which form the corners of the lines now have the tag SPH, so we have something to look for when we loop through everything. Okay, so we want to loop through everything on group 1, so we'll get a reference to group 1. If we can, I need to have the LogiX tool equipped. And everything on group 2 we will also loop through. But let's start out with 1. So we have this. We want to do a for loop, which takes a count as the input. So we need to know the number of children, which is back in slots. We want, can you see that? Yes, you can see that very well. In fact, you don't have to be looking all the way over there. Okay, anyway, children count. So children count is how many times we're going to loop. The slot is what we want to count the children of. We are going to say if the child, well, we have to get the child first. So we're going to get a child. We're getting a child index. That's the index out of the for loop. We're getting a child from that slot, which was group 1. And once we get the child, we want to look at the child's tag. So we do a get tag on the child, and that will tell us the tag of every child as we loop through it. And we want to say if, but we need an equals first because LogiX is kind of weird that way. So we need to do the equals before the if. So we're going to say if the tag is equal to SPH, which is what we just assigned. Okay. So what do we want to do if the tag was equal to sphere? We want to set its position to a random position. So let's do a set position, which is in actions. Why did I load up a drive? I wanted a write. So if the condition is true, we want to write something out to its position. I'll just keep going around in a circle here. How about that? So we loop through all children. If the child has the tag SPH, then we write something out to its position. Now, what do we write out to its position? That would be a random position that is within the distance limit. So we're going to have to look at the distance limit, its value, and there's something a little tricky here that I learned the first time around, and that is that this value is coming out as a double, and everything else that we're going to implement here expects a float. And currently Neos doesn't downcast from double to float, although it will upcast from float to double. So that will be fixed soon. Probably by the time anyone sees this video, there will be either a fix or a workaround. But right now, it doesn't work. So the hack that we use to get around that is we take its value, convert it to a string, and then parse it back out as a float, which, yeah, that really rubs me the wrong way, but it works. So that will give us a floating point value of what the numeric up-down control is showing, which will be 4. Why you make a liar of me? Oh, because I connected it to 2 decimal points. Sorry. There we go. Connect it to value and then it shows 4. You can't see that very well, can you? Look down more. So if I change the distance limit, it changes, and that is a float. I already said that. I didn't need to say it again. So we were doing randoms. Yes, that was under math. We want a random float 3 to give us a random position. And we want the min range and the max range. Obviously, min and max take a 3-component float, which means we need to go from that to 3 components. Go back to operators, pack XYZ. So we take the value out of the numeric up-down that has been converted to a float, and we pack it into a 3-component position, vector, whatever it is. It's an XYZ 3-component float. So that will give us, a 444, which works fine for the maximum of our random. But we don't want our minimum to be 444, and we don't want our minimum to be 000 either, because that would get this offset all to one side. So we're going to take that 444, multiply it by -1 to invert it, and that'll be our minimum. Yep, grab the wrong thing. So, we had a positive 444, now we have a negative 444. Let's put that into the minimum for the random. Let's look at what the random is outputting, and it is outputting a 3-component float ranging from -4 to +4 at each of the 3 components. And I don't know why it changes constantly. I would think it would only change as needed, but I'm no LogiX expert. So anyway, we have a random position. We're going to take that random position as the value that we write into each sphere's position, and this will only happen when this impulse happens, which is currently disconnected, but we're going to connect that up to the fire on change of the value. And we're done. That's it. When the value of the up-down changes, it activates this whole thing that loops through all the children on the slot for everyone that has the tag sphere. It says, whoop, that if doesn't have that if isn't attached. Okay. It will write out a random value from the negative distance limit to the positive distance limit into its position. Now I just need to connect this to something to activate the if, and I want that to happen on loop iteration. There we go. Okay, now that's done, except that we are only looping through the children of group 1. We haven't done group 2 yet. I forget whether group 1 was the red one or the blue one. Anyway, if I change this now, either the red or the blue should get smaller to fit within the defined limits. Let me set you at a wide angle here. All right, I'm going to hit smaller, smaller. Let's see what happens. That's a range of 4, 3. The red one disappeared. Oh, it's behind me. 2, 1. I don't think it's working. They all got stuck. Why did they all get stuck? Well, you can see the blue one is up there, just kind of juddering away, unable to move, and the red one is down here, juddering away, unable to move. All right, let's see if we can figure out what went wrong. Get you looking in the right direction again. Something like that. I don't know. Okay, so I would like to know what it is writing out to the position nodes. Let's see. I think I can just pull out its position. Well, no, because this is not... I know what I did wrong. I wrote out the position to the parent node, not to the children that we're looping through. That will not work. That will, in fact, break things that I now have to go fix. So let's look at the two groups, because we only moved one of them. So group 1, where is it? It's at 0.4, negative 0.3, 0.8. Group 2, its position is 0, 5, 0. 5 was to keep it up in the air, off the ground. So that will have to be adjusted with the limit 2 just to maintain the right height above the ground without appearing way up in the sky, but we'll worry about that later. So group 1 should be at position 0, 5, 0 also. They're supposed to be in the same place. And actually, why did I do a right? I didn't even want a right. I wanted a set local position. I was moving too fast this time. Well, that's okay. We can fix it. I should have realized when I used the right that I had the wrong thing, because that connects to a thing like this that you've pulled up. It doesn't connect to a child reference. Try that again. We want transform set local position. We don't want the right node. We want that to go away. So the position that we're setting is the child, not the parent that we're looping through. And the position that we're setting it to is the random, and the thing that triggers it is the if being true. Okay, let's try this again. I put the limit back up to 4, and you can look up there and see that they're bouncing around. I put the limit down to 1, and one of them should get small. Okay, there we go. So the red is obviously group 1 and the blue is obviously group 2. And you can see the red is freely bouncing around, and the blue, well, it's kind of stuck, juddering around with at least some of its points unable to move. Until I increase the limit back up to 4, then they're okay. So if we come back down here, we'll just want to do this whole same thing for group 2, which, let me see if I can copy the LogiX instead of actually rebuilding it. Okay, it's all en route now, which we don't want. If we look at group 1, this probably won't work unless I apply the LogiX and then copy the whole group, because one of the references is going to be wrong. But I'm going to pack the LogiX into group 1's LogiX by setting the packing route and then telling the logics to all go away. Then I don't know that this will quite work. No, because there was more logics in it than just... Oh. Why is my pointer not lining up with what I'm looking at? Why does group 2 have a whole bunch of logics in it? I think I screwed that up. Uh-oh. I think I accidentally packed the logics into group 2 instead of the group 1 logics. I must have grabbed the wrong thing. Yep, I broke it. That is no good. Okay, there is way more logics than we wanted. I did reveal logics, and that brought all of the logics for every one of the spheres controlling the corner positions back. And also, oh, I see. Yeah, I broke number 2. That's why the lines are no longer connecting. What is the chance that I can pack only this new logics and the old stuff doesn't follow it? I'm selecting group 1, logics, set packing route. Alright, let's see what happens. Whew, okay. We have the logics packed into the right place now. You probably can't see because you're zoomed way out, but all of the new logics nodes are now under the group 1 logics folder. And as far as group 2, I have thoroughly broken that, so group 2 is getting deleted. Okay. Why do I have all these floating nodes around? One more. Let's see if I can catch that. Okay, I think it's okay, but we're down to 1 group again. We don't have 2. So I'm just going to create a copy of that group, and it should copy all its logics and just work, I hope. I've forgotten. Is copy the green square or the yellow star? I think it's the green square. It is. I made a copy of that. Rename it group 2. You don't see any difference because it copied all of the positions and velocities, which means it's exactly overlapping. But if this worked and I changed distance limit, it will randomize the positions. And yes, I mean, they're both red, but we have 2 things again. And it should work such that if I make the distance limit 1, yep, they are both fitting within that 1, actually 2 by 2 by 2 meter square. Looks kind of strange. If I increase the distance limit to 5, now they're a lot bigger. It's working. Good. Increase the distance limit to 10, so we've got a 20 by 20 by 20 meter square they're bouncing around in. Okay, that was not exactly the most well-planned video, but it is working now, so I'll call that done. Goodbye.